at least learning about biomechanical engineering. So I think that's why Dave asked me to come in and kind of talk about that. So just a little bit about me. Like I said, I was an instructor a couple summers ago. I did it after I finished my master's, and I was going to go travel for a little bit, so I thought I'd work as a summer instructor, travel, and then get a grown-up job. So I pushed getting a grown-up job off for a little bit. So both my degrees are in mechanical engineering. So I did a bachelor's and a master's in mechanical. And in my master's, I focused in biomechanical engineering, which is super broad. Basically, that just means applying mechanical engineering to the body. We're basically finding tools that are better technology to use on the body for surgeries, artificial limbs, basically anything that helps people in an engineering way is kind of biomechanical engineering. So in my research, I did stuff on lumbar spine fusion, which I'm going to kind of describe to you today, because that's actually the area that I got a job in, which was kind of cool because I didn't know I was going to really work in the same field that I did research. So I work for a company called Mighty Oak Medical, so big Mighty Oak tree, and we're a startup company. I was the 10th employee, and we have just one product so far. I mean, we have a lot of products we're working on. We have one product that's actually officially released and we're going to use on patients. So that product is Firefly. So it's the Firefly patient matching technology. And so it's this guide, which I'll refer to as a guide right here. And I'll go into detail about what exactly that is. So I'm going to do a little background, just if you're unfamiliar with some of this stuff. So basically, this is our spinal column. We have 3 different regions of our spine. The upper region, which is all on our neck, is our cervical part of our spine. Then we have our thoracic, which is what's connected to our ribs. And then the lower part, we call this the lumbar, and that's just all our lower part of our spine that's not connected to ribs. And then we have our pelvis. So we got our ilium down here and our sacrum. So a lot of times people have lower back pain. You have parents, maybe they've complained about that. Hopefully you don't have back pain, but as you get older, there's a big percentage of people that will have some kind of back pain, and if it gets so excruciating, they'll end up doing a surgery. So I'm going to kind of go over a few reasons as to why you get surgery. This is just a few. There's tons of reasons. So one of them that I was saying, as you get older, sometimes people have degenerative disc disease. This is actually a natural process. Even if you don't have back pain, typically our discs in our spine tend to degenerate, which basically just means they start to wear down. So I kind of showed a little picture. So this is a disc that's in between each of our vertebral bodies that I was talking about in our spinal column. And the disc is kind of like a squishy material. It gets no blood supply, so once it starts to tear away, there's nothing to help build it back up. So that's why we have this deteriorating disc, which then causes some pain because if it deteriorates so much, think about bones just hitting on bone. We don't have that squishy layer in the middle. So you can imagine that would probably be kind of painful. So that's one reason. As people get older, sometimes they end up having to get this type of surgery. Another reason is scoliosis. And scoliosis can be congenital, which just means you're born with it. So if you're getting a surgery at a younger age, you probably have some minor scoliosis that they're trying to correct. Because once again, you're probably in some kind of pain. You might have a twisted back, which is going to cause other parts of your body to be affected by that, the force distribution changing. Then another reason is idiopathic, which means it kind of just occurs and we don't really know why. And that can happen when you're younger. Like you can not be born with any issue and then you get it. Or as an adult, you can sometimes get scoliosis. So those are kind of some reasons. That's why you might get a surgery. And then the other reason I put up, just once again, there's multiple reasons, but stenosis is another reason for getting surgery. And that's, so right here, in this space is where your spinal cord goes through. So stenosis just means that canal that the spine goes through starts to shrink a little. And that's usually because of something happening with our bone that's pushing that area to kind of close on our canal. And so then it's affecting our spinal cord. And then we get this pinched nerve and can be affecting our legs and everything. So that's just another reason why we might want to get surgery so that we don't have that pain. And by the way, interrupt at any time if you have any questions. Do you guys have any questions at this point? Okay. So there's just a few reasons. I just wanted to give you some background knowledge if you haven't heard of the different types of reasons why people might get a back surgery. And so then the type of surgery I'm going to talk about is spinal fusion. So that's where we decide to, because we have so much pain, we're going to go in and we're going to fuse the person's vertebral bodies together. So these are vertebral bodies, each one, and we're going to go in and fuse 2 or more of those. So once we fuse it, they're going to be one solid bone, and then we're going to lose that motion we have. So right now, you guys can all bend over, go sideways. You're going to have limited motion if we do that. Once again, if you're having a lot of pain, this could be helpful. So what they do for this surgery, they'll go in, if they're going in on the back side, so this is our back we're looking at, they'll go in and they'll put screws at each of the levels, and then connect however many levels they're going to do with a rod. And that's just to fixate and them all together and to provide some stability. So during that process, the bone, because they'll put in some other kind of proteins to get your bone to grow together. So during that process, this is just holding your bone together, and it will eventually fuse into one kind of solid bone. Does that make sense? Okay. So this is a spinal fusion, and there's a few different alterations to it, but that's kind of the basic detail of just spinal fusion. So I'm going to go through the process that we have for when we're helping someone for this surgery. We start off, and over here it says image acquisition and then virtual bone creation. Have you guys gotten to use a 3D printer or anything? Okay, so these are both 3D printed parts, and I'll kind of talk about them a little bit too. So we start off with a CT image. Do you guys know what a CT image is? No? How many of you guys have had an X-ray? Yeah? Okay. So a CT image is kind of like an X-ray. It's actually multiple X-rays, and it's taken all around your body so that we have projections in 3 different directions of your body. So it's very similar to X-ray, but we're taking a full rotation of your spine. So I kind of just showed this image. This is showing that you'll have like a huge kind of scanner around your body, and it's scanning all around so we get projections on every level, or on every angle. And then from the CT scan, so this is what it will look like. So we'll have 3 different views. And if we have 3 different views, what do you think we can do with those 3 different views? Or what's before the 3D printing? Make a 3D model, 3D virtual model. So that's what we do. So when we receive a case or a surgery, we'll get a CT scan, and then we can we do a process called segmentation. So I don't know if you guys can see very well, but we got outlines of different parts of the vertebral body. So right down here is the sacrum, and then this is our lumbar region that I was kind of showing you. That's our lower back. And then we create this 3-dimensional model. Have you guys been using, what's the SolidWorks 3D program you guys use? Or is anyone using anything mechanical?
I know Marilyn's been doing some stuff in SketchUp.
Okay, yeah, SketchUp. So we don't use SketchUp, but we use SolidWorks, which is kind of like SketchUp, where you probably wouldn't be able to do this in SketchUp just because it's an anatomical model. But in a program similar to that, we can take this and put it in there, and then we can start looking at it and doing, let's say, like if you've done a cut in SketchUp, you can technically make a cut on this or something. Not that that's what we do, but just to give you an example. So once we have our 3-dimensional model, we then plan trajectories for those screws. So you know how I was saying we put the screws in on each level? We plan with the surgeon, of course, since I'm not a surgeon, I don't have a medical background at all. I work with the surgeon that's going to be doing the surgery on our patient, and we plan these trajectories. And I just put this sideways so it fit. It might look kind of funny like that, but these are showing the trajectory of our screws. Do you guys know what a trajectory is? that term, really? You understand it? I mean, basically we're just choosing that path of where the screw's gonna go. So this is just an illustration in SolidWorks, kind of like a program like SketchUp. We can choose our trajectories and throw them in our bone model. And then we talk with the surgeon and he approves those planned trajectories. So this is all pre-surgical planning way before the surgery happens. And then from that, we're gonna then next make our guide. So on this guide, these cannula right here are mechanically forcing these trajectories to happen in the surgery room. So what I mean by that, and I'll show, well actually I'll just show that in a second because it'll make more sense once I put all the tools in here. But after we plan these trajectories, these will be restricted by this cannula right here. And then we make this guide, which on here you'll see these are the contact areas on the bone. Do you have a question? Okay. So right here I'm just going to show you how it will fit. So this is someone's spine, by the way. This is 3D printed, just the lumbar part. It goes from L1, so we got L1, 2, 3, 4, and 5, and then this is part of the sacrum. It's cut off. The sacrum really goes all the way down here. So this guide was specifically made for this vertebral body. And so you can see this guide, and I'll let you guys play with this a little bit, but it's fitting onto the anatomy of this person. And so we make this guide to fit onto there, and then the surgeon can drill through these holes to pick the trajectories that we planned ahead of time. And so what that looks like So we'll put the sleeve in there, and then this is a drill bit. So just like if you were drilling into a piece of wood, this is kind of how they do this under spine. I know it's kind of gross to think about, at least I don't like to think about it, but it is how it works right now. So they'll put the drill in, it's connected, and they'll drill into your bone. Then once they've made that, and you can see that this is restricted, right, by this cannula. So now we've planned it in 3D on our computer, and now we're restricting that drill to go down the path we've chosen with the surgeon. Does that make sense? You can say something if it does make sense and I can explain it better. You get it? Okay. Then once we do that, we put another sleeve, and then we do, they typically will tap. So basically just threading that hole so that the screw is ready to go into it. So you can see that's the thread end. So they then tap the hole, and then they take this off, and I don't have any screws with me, but they would then put in a screw into that hole we've just drilled out in the bone. They do it on both sides and on all levels that they're going to do the surgery on. And so I'm going to show a little video because it really illustrates it, what I just went over with you in a nice way. And then after that, we can open up to questions and you guys can look at the guides on the actual spine. So we start off with our spine bone model. We put the guide out. So the guide's going on the actual patient's spine in the surgery room. And we're drilling our holes. Or first we're fixating to the bone. Then we drill each hole. I'll go in and tap, so just thread that hole so the screw will follow the path. And then the guide comes off. And they'll put in their screws. And so so why do you guys think this would be important. So I guess I should say right now, if they're doing what we call freehand, they're not using any guide, and they're basically going in, they'll open you up for your surgery. They feel for your anatomy, and then they choose and just freehand drill in to the vertebral body. So what do you see, why do you think this is beneficial to have the guide?
Are you the only ones doing anything like this?
There's other forms. Ours is the only one that is an actual product that you put on the bone.
There's other forms of guide versus.
There's other forms of navigation, so that's the kind of term that the umbrella we're under. So there's other forms of navigation where they do, they'll take scans intraoperatively, so this means during the surgery they're taking scans to see where the screw and the drill is going. The thing about that is it provides more radiation to the patient, and so we're trying to kind of reduce that. I'm sure you guys have heard people maybe talk about that, or that's the reason why scanning and everything is not as good, or we want to limit that from patients because radiation can cause health issues later on. So do you have a question with that, or?
The question was, are you the only ones doing this?
Okay, I didn't know if you had a follow-up question or anything.
Yes. You are. The only ones doing some sort of like physical guide?
Yeah.
That's cool.
And so basically, the kind of overall reason for doing it is doing pre-surgical planning ahead of time so that the surgeon is not looking around for where he's going to put the drill. Kind of can provide safer trajectories, because if I put in a screw and it goes out over here, that could be a big health issue. We have other, organs in our body, right? So if I don't know what I'm doing, the screw goes all the way out here and hits something, I might have some issues later on. So it's basically providing kind of safer screw placement for surgeries. And you can see on this one, does this look like a normal spine? So it's a little curved. This is a slight scoliosis spine. And I actually did one that was a lot more scoliosis than this. Like the patient was actually bent sideways and forward. Yeah, they're not anymore though, because they just got surgery. But so other reason for using this is when you have very unique patient anatomy, when we don't have this straight spine, we have this curvature. It kind of helps the surgeon out ahead of time to plan where he wants those screws to be placed.
If the disc is the one that's breaking out, why would you put the screw on the foot?
Yeah, so we don't, so this is right here, right? And if it's deteriorating, like I said, since there's no blood supply to it, it can't fix itself. So there's really nothing else we can do. So if you're having lots of pain and we want to keep that height, so let's say it's deteriorating, so that vertebral body is going to be coming closer to the other one. So what they'll do is they'll also put in an implant. We just don't design any implants or anything. They'll put a little implant in there, and then they put in the screws and the rods to help fixate your bone in place. And that's because if it keeps lowering, you're going to keep having pain. It's just to kind of prevent you from having any more pain. So does that make sense? We're kind of keeping that separated so you're not getting the bone knocking on each other and that pain from that. That's a good question. It keeps basically keeps your height.
Holds it up and screws.
So you guys know, when older people are saying like, I'm shrinking, it's really true. Our discs do start to, deteriorate, and so, you can lose some height. Any other questions about?
Usually, what's the kind of material that the guide is?
The guide. So our guide is, I'll pass it around, you guys can hold it. It's a 3D printed guide. So it's this material. And, it's a proprietary, I don't know the actual material, but it's just a type of plastic. Different plastic than if you had a 3D printer at home. It's also autoclavable, which means that they can put it through sterilization. So if you're going in for surgery, everything that they're using is going through a huge sterilization process. So that material has the ability to be heated up to sterilization temperature that can be sterilized. So I'll just show you real quick. So there's a different one for each level. And on the side, you'll see that it says L2. And on the front, we also have labels, so L2. That one's gonna match that. But you could also play with trying to put it on another level. It won't fit because it's specific to that level. And that patient's anatomy. Like these are, once we use that guide, it goes in the trash. Everything else we reuse, but the guide is patient specific, so it's a one-time use.
If your girl is currently into the bone, wouldn't that happen to the bone?
If you're what?
If you're like screwing into the bone, wouldn't that happen to the bone?
So in the vertebral body, there's trabecular bone, which is like a spongy type of bone. And then on the outside of the vertebral body, we have this like hard bone. That's all that's there. And actually when you get older, that bone, the trabecular bone, is also deteriorating. So a lot of patients we're working with, like if they're an older patient, their bone is really crappy. So we're typically trying to put in like maybe a longer screw to help get more fixation. But we don't really care about the bone at that point. All we're trying to do is get as much bony fixation in that screw at that point. Yeah. Yeah, so this is an older patient. You can see like that's a really small amount of space between your vertebral body. You should have, more than that. It's definitely been deteriorating. You can see all this bone that's coming off like that. That's all called osteophytes. That also naturally kind of happens as we get older. So our bone can actually sometimes naturally fuse a little bit. So the bone will, from one level to the next, will kind of grow out and then those will fuse. Sometimes we can have some natural fusion of our bone.
Did this patient have multiple levels of screws, or was it just this?
No, you would have multiple. You at least have to have two because the rods have to connect between two sets of screws. So typically though,
So they put like 2 screws here and 2 screws here around.
exactly, because then they're holding to each other, they're fixating to each other. Typically though, we're going to be working with someone doing it all the way through this. So just be careful passing that around. Yeah, check out putting the guide on there.
Goes on LC.
So when you said like you screwed through, or the picture you showed, it was like 3 sections, right?
Yeah.
Did they actually become one bone, or did they function like one bone?
Yeah, so you mean when they fuse?
Yeah, like is it actually one bone? Like no more sections?
Yeah, it will kind of like pretty much anywhere where the bone is at a joint area. So yeah, any of the joints will then fuse together at that point. 'Cause they basically will get rid of any tissue, and then they'll grow together, and then they'll act as one unit.
Okay.
Sometimes though, that fusion doesn't always occur because of course we don't, our bone will do it and we'll put in some things to kind of help the bone grow quicker. But sometimes people can have failed fusions where it doesn't actually fuse together.
Yeah, don't they feel like a lot of stress? Because I mean, I understand because some people they do like knee surgery, but that's only like limited movements. But like for your like spine, there's a lot of movements. Wouldn't they feel like a lot of like pain?
Yeah, I mean, so this is why you're only getting this surgery if you really need it, or if you're in a lot of pain. You'll still be able to bend some. It's just gonna eliminate a lot of that motion that you have because we're gonna be getting rid of those joints we have that are helping us.
Yeah, but like when you're trying to do those motions, wouldn't that put like a lot of stress on your bone with the screws on?
Put stress on the rods.
Yeah, so the problem is the once it fuses, yes, that is an issue to where once it fuses, it is acting as one unit and the rods aren't really doing anything at that point. So a lot of times, if you are getting this type of surgery younger, eventually other levels, because they'll take on more of that force, and then other levels will eventually need to be fused as well because they are then taking on more of the load.
So you just keep adding on.
It can be like that, yeah. Typically though, if this is happening in older people, they're probably not people that are moving a lot anymore at that point,
Yeah.
sadly, but in the younger patients, they'll do different things. But yeah, that's a good question because yeah, you have a higher risk of a revision surgery once you get it. But you have a while. It's not like it happens immediately. So,
Yeah.
yeah, it's definitely a low distribution once it fuses. So ideally, we hope to come up with other things that you can avoid the surgery. like right now, they don't have, they're looking at making artificial disc replacements. So what you were saying about like, why are we, screwing to the bone when, and all we're doing is just trying to restore that height. But they are looking at, artificial disc, actually replacing that disc. The problem is figuring out how to keep it in there. Right now, the way our bodies are made, it's pretty impressive that our discs just kind of stay in that, well, hopefully stay in that position. But if we were doing artificial disc, we'd have to figure out how we would keep it there. Because there's nothing holding it there except for the pressure between the two vertebral bodies. Does that make sense? So that'd be a really ideal way of helping restore the height. Any other questions? It can also be about other stuff too. If you're interested in something, are any of you guys interested in biomedical or? You're interested now? Why don't we go around and tell me what you are interested in or what you think you're interested in at the moment? I'll start. I don't know your name. You're start with what you're interested in for like engineering? Not sure yet? Not even like mechanical or computer? Okay. And then what were you interested in before biomedical? Architecture? Okay. How about you? Okay.
Automotive.
Automotive? Alright, so probably mechanical path?
Mechanical and
Okay. What do you like about mechanical?
it's like more hands-on.
Yeah, it's true. Lots of things that move. And mechanical is pretty, I know I'm biased because I'm mechanical. But mechanical is cool because you can do kind of anything with it. There's just so many aspects of mechanical, like the automotive, the aerospace, the biomedical. There's a lot of areas of mechanical engineering, super broad. So sometimes, like for me, I didn't know what I wanted to do, so doing that was great, and then I could choose kind of what I wanted to do. You guys have
It's really cool.
What'd you say?
It's really cool. Taking building.
Yeah, I mean, I don't know as much about organ donations, but yeah. There's certain organs you can only, I think you can live one to or something, I don't know. Not, so once again, I'm an engineer. I know about some medical stuff, but I didn't take like much anatomy classes or anything, so. But I do think the area is very interesting, so I'm constantly kind of learning new stuff about the medical world. But I didn't go to medical school.
Did you have to take like biology classes?
No, because my degrees were mechanical engineering. I wanted to take an anatomy class, it ended up not working in my master's, but now I just kind of learned anatomy on my own.
You know, was it like hard, like memorizing stuff?
Well, I mean, I think as engineers, like we don't need to know everything about the body if we're working in like one area. So I think it's kind of a little bit more, like I learned a lot about the spine. And then if I were to start working on like knees or something, I'd probably learn a lot more about the knees and stuff like that.
Yeah.
I mean, it would be helpful. I mean, I definitely wish I would have taken an anatomy class. I don't think taking biology, like I did actually take biology. Biology goes over so much stuff though. I mean, that's your animal and human biology. You got your cellular biology, all that stuff. I knew I wasn't interested in like cellular bioengineering, so I thought biology covered a little more than I wanted to know. And I'm not good at memorizing a ton of stuff, so I would say if you were to do something like this, you'd want to take like an anatomy class, and that'd be pretty helpful. Yeah. Any other questions?
How do surgeons actually remove like part of the bone?
How do they what?
Remove part of the bone, like Parkinson's.
How they remove it? Well, the drill is what creates the path for that, taking that, moving that bone. Then they have other tools like on the back side where the vertebral bodies connect. That's their joint. So they'll go in and they like have this tool that just yanks it off. So they're not like super. They're pretty rough on your bone because your bone is. I mean, they treat your bone's hard, so they have to act with force on the bone. So it's not graceful. It's kind of. I mean, I've been to a couple surgeries recently, and it's a little interesting to watch because they're kind of banging on the person's bone. Person's asleep and knows nothing, so that's good. But
Making me not want to get spine surgery.
Making me not want to get surgery.
I don't think you should want to get. You shouldn't want to get surgery. If you need it, you might have to.
It's like pretty bad.
No, I mean, it seems bad when you don't know much about it, and that's why I'm just saying that. There's obviously a lot of surgeons that do great, and people are really great after surgery, so if you need it, it can be very beneficial.
How did they actually get in the bone? What did they have?
So yeah, if they're going in on the backside, they cut open. So you have your skin, they have to move all your muscles, your nerves out of the way. So they give you a lot of relaxants so that all that can move aside, so that they can just be looking at your bone. And then they'll remove some tissue off your bone. And then they have tools to kind of hold it all apart so that they have a working space to do the surgery.
And it sounds intense.
What?
Sounds intense.
Yeah.
And how do they build that tissue to the bone?
How do they what?
They build it back up when they do that tissue.
Yeah, so I don't know. That tissue's not necessarily. They remove the tissue, and then I don't know if it's like natural that we kind of get some more tissue back. They'll put in back, so they'll take off some of your bone and they grind it up, and then they put it back in there. And I think that kind of helps restore it, but I don't know as much about that part.
But don't bones just grow back like that? Because some people they get like cut off a part of the skull,
Right.
then the bones recover, right?
The bone does. I just don't know about tissue growth
Okay.
specifically, because he was asking about because they scrape off all the tissue off your bone.
Oh yeah.
I'm not sure. I think it does. The tissue will kind of grow back, but I don't know as much about the tissue.
Depends on the type of tissue, I believe.
Yeah, I would assume. They're doing a bunch of stuff with tissue engineering to try and stimulate some of that, but yeah, tissue engineering is another area you can go for, like bioengineering. That's a pretty cool area right now because they're trying to use tissue engineering to, grow body parts and stuff.
Well, they're already pretty body parts, so probably not that far off.
Yeah. So, any other questions?
What do they use to secure the guide into the bone?
Yeah, so on there, you'll see, there it is. So on the sides, we have these cannula over here, and then we have just these tiny little screws that we use to fixate to the bone temporarily. That one's kind of a little bit into the bone, but it basically just fixate a little bit, and then they can do the drilling. And it does add a little puncture in your bone, but there's not really any issues with that, so it's just a temporary fixation. Depends on how many levels they're doing. I've been into really long ones where, and so when I say levels, that's the vertebral body is one level. So the last one I was in, they were doing 17 levels. The person was getting from their top of their thoracic all the way down to their pelvis fused together. And that one took, I think the surgery started around, I think the person was maybe opened up at 9, and then it went to like 6.
Is it just one surgeon if you feel like time?
So you have a surgeon, and then you have a whole surgical team, first of all. And it's pretty impressive how they all work together. So you'll have a surgeon, and then he's got his PA, so it's a physician assistant, which is basically like a surgeon. They didn't go to as much school, but they basically help assist the surgeon. And then you got your surgical team, which is passing on the tools that you need at the time.
No, but not just that, because being the surgeon, being like the guy in the body, it's gotta be really exhausting to do that for
Yeah.
9 hours in a row.
Did they have lunch breaks?
They do have breaks. The surgeon doesn't have to come in right away, because they'll kind of get the patient ready, get them hooked up to everything, do all that preparation. But they are in there a while. They'll take a little break, especially in the long ones, because sometimes surgeries can take like half day. The long ones take like a full day. I'm always worried about their necks because they're just like, looking over someone's spine for so long. And,
And they're gonna be expensive.
I still look
I think
at
they're pretty good about trying to keep themselves straight up because they know that they're going to be in pain.
it's funny. It's like, I'm going to do this so I don't have to be in his spot.
Yeah. So, is that any other questions?
What is it called, the person that cuts? all the tools and like have the specifically.
The person that has the tools, they're called the scrub tech. And I don't know why.
My mom used to do some of those.
Okay, she passed the tools.
Yeah, she said that
It was what?
it was a lot of versions because it was like smaller versions of each tool.
Yeah. The scrub tech is like very important. I mean, they've got basically how it's set up. They'll have a whole table of all like different types of drills and all their tools that they're going to use for the surgery. And I mean, it's kind of cool to watch them. They know what they're doing. They learn a lot about the surgery, even though they're not the surgeon. They're doing so much with knowing what tool they need at the time.
They're ready for most of the time.
Yeah. Huh?
They're ready for most of the time.
Yeah. Because we've done some kind of cadaver labs, so doing this on a dead person's bone, and so I've been on the surgery or done a surgery with a cadaver, and the surgeon I was working with kept being like, pass this, and I was like, ah! It's definitely if you don't know what you're doing, it can be kind of an intense position. So. Any other questions? Hope you guys found this interesting. This is just one little area of kind of biomedical engineering. There's lots of areas. Also, even if you're an engineer, it doesn't mean you have to be in the surgery room. Things like that gross you out. That doesn't mean that you couldn't do this type of engineering. I like to be in there. I think it's kind of cool to see it, but not everybody likes to do that. Some people just faint.
So you can go in there if you want.
If what?
If you want.
I mean, the surgeon has to want you in there.
Oh, okay.
Yeah. You have to pass a lot of background checks and tests and stuff to make sure that you can be in there. Yeah. You're just in the room. You don't touch the patient or anything.
How do the surgeon know which guy goes on which bone?
So we add these level markers. They're kind of hard to see, and we're trying to work on maybe being able to 3D print, have some color on these letters or on the markings. You can see right here it says S1, so that means that goes on the sacrum. So what they're supposed to do is kind of check the guide before they look at the level, and then put it on the whatever bone level it's supposed to be on. They also, though, these will only fit, so it's registered to the unique anatomy of that bone, so they could try to put on a different level and it shouldn't fit. So those are kind of two different checks. This one's kind of cool, so I'm going to show this one too. So down here is the sacrum, and then these are the iliums. They're very small, they're actually huge, right? It's just we cut it off. So this guide, for the ilium, is one guide, and you drill 4 different holes. So here you're drilling the holes for the sacrum, and then if you're fixating to the ilium, you also are drilling holes right there. So this one's kind of a cool guide because you can see 4 different trajectories are on there. So, and this is kind of one that surgeons do like to use because when we open up the person's body, you don't want to open up too much, and the ilium goes way out here, so they like to have kind of guidance because it's harder to see where to put the entry point. So having this is kind of helpful in this situation specifically.
How much work is it going to making?
The pre-planning.
Yeah, I mean, because you come up with some kind of new method of doing the surgery. How do you
Right.
convince the surgeons
Yeah.
into doing it?
So right now it takes about 3 to 4 weeks to go through the whole process. And we're not necessarily working on stuff that whole time, but 3 to 4 weeks, that's including the 3D printing and it being shipped to the hospital. So basically, if a patient's going to get a CT scan though, they would have had it 4 weeks or more. So basically, as long as we can get that CT scan within 4 weeks before the surgery, we can design guides. But so yeah, how it works is if a surgeon thinks that they'll need the guides for a certain case, they will send us a CT scan and we get the order going and then build the guides. They're using it for more complex cases though, like this one would be a little bit more complex just because of the scoliosis.
Yeah.
We haven't done one on a straight spine, so it's always a new and exciting thing. The worst one I had was, and I'm not kidding, the spine was like this, and like this.
Wow.
So like almost a 90-degree
Wait,
curve.
what?
Yeah, that's the patient I was saying that is kind of weird. So that patient had 110 degrees of scoliosis. So not only was it rotated over, and it was also a little twisted. So look up if you want to. I don't have any pictures, but
Did they walk straight after or no?
they're actually fairly straight compared to what they were now, or what they were before.
That's pretty awesome.
Can you tell when someone has,
But
can you tell when somebody has?
yeah, well, if somebody has some like major scoliosis, like I was saying, you would see that they're probably hunched inside or forward. So like like I don't know if any of you guys have grandparents that are like hunched forward, or you've seen an older person that's hunched forward. So that's a curvature that we have right at the top. It's called kyphosis, and so just the top of my spine is curved forward and forcing me to be like this. Whereas scoliosis is going to involve some rotation too. There's lots of reasons for different things, but yeah, if somebody's probably hunched over, they probably have something is twisted in their spine. Any more questions? Did you pull up a picture? I was like, I saw your face. Do you want to show? Do you have an X-ray yet for
Oh
somebody?
god, these are just wrong. It's like I don't think I have the one you specifically had, but there are some of these that are just
No, that one was pretty bad.
not.
Like if you see an X-ray, sometimes that's helpful too, because you can see the correction of osseous spine. Which one?
That one's just it's going.
Yeah. Yep. It's hard to imagine, but it is.
What?
What do their ribs look like?
Did it
Yeah,
just
so their
displace
ribs are
all of his
all-
muscles?
Right now, like their
Dude,
ribs are
that's
very-
ridiculous.